in our first two videos, we talked about sine and cosine graphs, and in this video, we're going to talk about tangent graphs. All right, so tangent graphs are, going to obviously look a little bit different. You can see that by the visual that you have on the screen. All right, but a tangent graph will also have asymptotes that we need to look at. All right, so we still have a midline of y equals 0, which is your y equals k. And we haven't talked about shifts yet. Okay, so we've seen a little bit of reflection, but we haven't done anything with shifts yet. Those will be separate videos. All right, so I want you to notice that right here it gives you the equation of a period, and instead of being 2 pi over b, it's just pi over b. All right. And you still have 4 increments, 1, 2, 3, 4 increments. So like there's still 4 quarters, but I want you to notice that it's not all on one side anymore. It's kind of split in the middle. So half of it is on one side, half of it is on the other side. So your asymptotes will be 2 increments over and 2 increments over, basically. Okay, so multiples of pi over 2b. All right. So you will have asymptotes. We're going to also have halfway points. So this point is considered a halfway point. This point is considered a halfway point. And basically, because it's halfway on this side, halfway on this side. Okay, that comes from. Um, your domain will be all real numbers except odd multiples of pi over 2. Okay, and that's just because of all these asymptotes. All right, again, we're not going to get too deep into domain and all that stuff, but it will be there. The range is negative to positive infinity because even though the domain is restricted by the asymptotes, this graph, it technically keeps going up and up and up and up and up and up and up. Okay, and down and down and down and down. Okay, so that is continuous in terms of that direction. All right, so negative to positive infinity. All right, instead of having a period length of 2 pi, like sine and cosine graphs, the tangent graph has a periodic length or a fundamental period of pi. So it is still periodic. That just means that the cycle repeats over and over and over again. Okay, but it's just a little bit different in terms of how it's laid out on your graph. All right. So some things that will help you, your tips here, is that your asymptotes occur at 1/2 of your period. All right. And then your halfway points occur at plus and minus 1/4 of your period. So you can utilize this to help you get these answers down here as well. But I'm going to show you how to do that on an actual graph. All right. So for this example right here, the first thing it's asking for is our amplitude. Well, the amplitude is right here. Amplitude is 3/2. That doesn't change. All right. The period is where it changes. So this is still B. B is 4. But this time we're not doing 2 pi over 4. It's just pi over 4. And you can see where people probably mess that up a lot because, it gets a little confusing. Like, am I using 2 pi over B? Am I using pi over B? And sometimes you have problems that are just kind of intermixed. And then it's kind of easy to just like, oops, and not pay attention. All right. So since our period is pi over 4, all right, remember the asymptotes occur at 1/2 of your period. Okay. So plus and minus 1/2 of your period. So for my asymptotes, I'm going to have 1/2 of my period, which is pi over 4. Well, what would that be? That would be pi over 8. Okay, so before I get too far, I want you to think about our 4 increments. So instead of going 4 over, we're going 2 over and plotting an asymptote, and 2 over the other way and plotting an asymptote. All right, so remember, an asymptote is kind of like those imaginary lines that your graph approaches. All right, but in this case, your graph will not cross over these asymptotes. So it's just going to simply approach. All right, so if the whole period is pi over 4, then halfway is pi over 8. Another way that I like to think about this that may make it a little bit easier for you is to think about your quarter marks. Okay, so I'm not going to do all of these in purple. All right, so if my period is pi over 4, think about that, 4 increments. What's half of pi over 4? Pi over 8. I'll do this one in purple. pi over 8. Well, what's half of pi over 8? Pi over 16. All right, well, if these are the positives, then what are these? Well, they're just the negatives. So this is negative pi over 8. And if this is pi over 16, this is negative pi over 16. This, of course, is still 0. All right, this is still 1, 2, 3. All right, that part doesn't change. Okay, but I want to talk a little bit more about these formulas. Okay, so we had our asymptote was 1/2 of the period. So 1/2 of pi over 4 was pi over 8. Positive pi over 8, negative pi over 8. If I want the halfway marks or halfway points, then it's just 1/4 of your period. So 1/4 times pi over 4, which is pi over 16. Now remember, you've got the plus and the minus for both of these, okay? All right, so that's where these numbers come from mathematically, or if you just use it by counting. All right, so what happens is a tangent graph, the middle point, okay, that midpoint right here, will start at 0, 0, okay? And then it's going to go over and up in amplitude and then just keep approaching. It's going to go left and down in amplitude, but then keep approaching. Okay, so you want to kind of think about the curvature of your graph. All right, so we're going to have a point at 0, 0. The only time that changes is when we start introducing shifts, but right now we're not doing shifts. So I'm going to go over and up in amplitude. Well, my amplitude is not 1. What is my amplitude? 3.5, which is really like 1.5, right? All right, so I'm going to go 1.5 up. So here's my point. All right, and I'm going to go left and down 1.5 or 3/2. And there's my point. So what I will do is I will take this middle point right here and it's going to curve up towards your asymptote. And then I'm going to go back to my middle point and I'm going to curve down towards this asymptote. Okay, so it kind of does like a little squiggle in the middle of your graph. Okay, so my intercepts, I only have one intercept in this case, which is 0, 0. And then I have my asymptotes at x equals pi over 8 and negative pi over 8. So plus or minus pi over 8. Now, when your graph starts shifting, you may have to separate that out. It might be like x equals pi over 8 and x equals pi over 2 or something like that, okay? My halfway points are actual ordered pairs. So I have a halfway point at pi over 16, comma, 3/2, and negative pi over 16, negative 3/2. As much as possible, stay away from decimals, okay? So even though I know that's 1.5, just be really super mindful of that. All right. All right, so that is one example at the bottom of page 9. All right, so flip over and try this one. All right, so for this one, we have an amplitude of 1/2. So amplitude is always in the front. Period is going to use the b value of 1/3. Now it's not 2 pi over b, it's pi over b. So pi over 1/3. But since we are dividing by a fraction, we're going to multiply by the reciprocal, which gives us 3 pi. All right. Now 3 pi is the length of 4 increments. But remember, our increments are split into halves, right? So to get the asymptotes, we're going to say 1/2 times the period of 3 pi, which is 3 pi over 2. All right. So this is 3 pi over 2, and this is negative 3 pi over 2. These are our asymptotes. Okay. Now from there, we still need our midpoints right there. So we could say, I'm going to put halfway. All right, would be the quarter marks. So 1/4 of 3 pi is 3 pi over 4. So this will be positive 3 pi over 4, and this is negative 3 pi over 4, and this, of course, is still 0. All right, well, 1, 2, 3, negative 1, negative 2, negative 3. All right, so that's kind of where all of those little markings on our graph comes from. So now we're going to figure out, well, how do we graph it? Well, if it's a tangent graph, now there's no reflections, okay? So we don't have to worry about that, but our tangent graph in the middle will be at 0, 0, unless there's a reflection. It's going to go over and up in amplitude. Well, my amplitude is only a half, so just right here, and then over and down in amplitude right here, which I know it's kind of hard to see since it's on top of my negative 3 pi over 4. All right, but we are going to go back to our center. We're going to curve up through that halfway point towards our asymptote, go back to the middle, and curve down through that halfway point towards our asymptote. All right, so that's what our tangent graph looks like. If we reflected it, this part would be up, this part would be down, and it would kind of curve this way instead. Okay. All right. So now we're ready to answer the questions about our intercepts and such. So our only intercept is at 0, 0. Our asymptotes, we already calculated that anyways, but it was x equals plus and minus 3 pi over 2. Okay. And then my halfway points, I have positive 3 pi over 4, 1/2, because it represents the amplitude, and negative 3 pi over 4, because negative 3 pi over 4, down in amplitude, which is a negative a half in this case, because it went down. Okay, the amplitude is just a half, not negative. Can't be negative, it has to be positive. All right, so quick reminders, amplitude measures how far from, your midline, basically, how far up, how far down do you go. In this case, the amplitude is kind of not really a traditional amplitude, so you don't really necessarily want to call it amplitude, but it is, it gives you kind of a frame of reference. Okay. All right. So another example, and I'm going to kind of pause the video. I want y'all to at least give this one a shot. I want you to do as much as you can, even if that's just amplitude and period. Just go ahead and give it a shot. All right, so let's go ahead and look at this one together. All right, so the amplitude was 3. All right, which, remember, this isn't a traditional amplitude, so just be mindful of that. We're just using that to kind of help us with our halfway points. All right, and then our period is going to be pi over b, and b in this case is pi over 2. All right, so pi divided by pi over 2. Well, we are dividing by a fraction, so we're going to multiply by 2 over pi, which is the reciprocal. Well, the pi's cancel, so 2 pi over pi would give me just 2. So I have a period of 2. All right, now again, our formula that will help us out for the asymptotes is 1/2 of the period. Well, the period is 2. So what's half of 2? 1. So 2 over will be positive 1. 2 over will be negative. Oops, well, make that extra long negative. All right, negative 1. So those are where my asymptotes will be. Remember, your asymptotes are split. Okay, so we have a period of 4 increments still. It's just instead of being all over here, they split it half here, half here. Okay, the y-axis is in the middle. All right, so this is a positive 1. It's kind of hard to see that. All right, so now to get the halfway markings, the halfways is going to be 1/4 times the amplitude, or the period rather. So that would just be 2 over 4, which is a half. All right, or half of 1 is a half. So it's not that hard. But all right, so this is positive a half and negative a half. And this is always still, of course, 0. All right, so 1, 2, 3, negative 1, negative 2, negative 3. All right, so let's go ahead and plot our points. So we are plotting our points. It starts at 0, 0, and then it goes to my halfway mark, but up to the amplitude number. and then to the halfway mark and down to the amplitude number. All right, so this one's a little bit harder to graph because we don't have that much space up here, but it's going to curve through, and you just have to kind of know that it's going to keep creeping over, even though it's hard to get it to show that on here because it is such a steep looking graph. And then same thing here, it's going to keep curving. All right, so that's what that graph will look like. Now, sometimes people struggle with how do I do that? So I do want to show you this one in your calculator as well, because we did that with the sine and cosine graphs, and I failed to do that here. So this is what you could do if you wanted to like double check your points. All right, so we have 3, make sure you're in radian mode again. So 3 tangent of pi over 2 times, and in this case, we have a -1, right? So that's -1. And you'll notice I got a domain error. I got a domain error because it's a what? An asymptote. So not a shocker. All right. So now we're going to do that at -1/2. And I got -3, which is the point that I plotted. Do that again, but I'm going to do it at 0. And I got 0. So that's why I have a point at 0, 0. Do it again, but this time I'm at +1/2. Whoa, that was messed up. Let's try it again. And I got +3, so that's where that point comes from. And then if I do it again at +1, I'm going to get a domain error because it's an asymptote. And that's what happened. I got a domain error. Okay, so I just wanted to show you that you don't necessarily have to remember exactly how it goes. Okay, it does save a whole lot of time, but you could definitely use your calculator to secure those points as well. All right, so my intercept, the only intercept that I have is 0, 0 again. We'll get to the after a while. My asymptotes are at x equals plus and minus 1. And my halfway points, I had 1/2, 3. And -1/2, -3. Okay. So hopefully you got some of that correct. If not all of it, that would be even better. But just want to make sure that you are practicing. All right. So your assignment that will go along with this comes from our HMH book, but I went ahead and put them on here so that you could graph it a little bit better. So it was page 468 in our HMH book. Numbers 21 through 32 even is what I put on here. Okay. So for y'all, that is page 11 and 12. And '13 is the tangent graph. So we definitely want to practice all of those. Okay. So basically, page 11 through page 14 for extra practice.